Let's take a look at this problem. Let me give you an overview, and maybe you can figure it out from here. I will detail all the other parts here, but this is a four rectangular slit thing. So this is on its way to becoming a diffraction grating. Okay. Now there's two things going on here. If you look at this, and you can see the pattern here, right? If you have only one slit, then you've got this diffraction grating pattern, and this diffraction grating pattern is due to the width of one of these slits. Okay, so I don't know, we can call that B, the aperture or something like that, right? Okay, and then we know that this angle there, right, the sine of that angle is basically the wavelength over that B. And I think in the other text there was a big D or something there. Okay, so this angle right here is the overlying pattern. You see that dotted line like that? Okay, that pattern is caused by the single slit diffraction pattern of one of these slits. And this angle right there that you see, okay, that overlies all of these other ones. So here's a double slit, here's triple slit, here's four slits, right? Okay, these bright spots are the same bright spots, these guys here, okay, that Young's double slit has, but they are modulated by that single slit diffraction pattern. And the width of this thing is, is the sine of that angle is lambda divided by b. Okay. Now this is of course in radians. Okay. This is going to be in radians here, so we got to be careful about that, right? Now these particular maxima here that you see, those are the Young's double slit maxima. So the other thing that's going on here is that we've got the n lambda is d sine theta, right? There's also this separation here, right? There's the S is lambda d divided by d, okay? Or lambda over d is S over big D, right? Where d is the distance to the screen, this is the slit separation, this is our, right? Okay, that's our S for that, right? This is, of course, the legitimate equation. This is the approximate equation, okay, which for small angles works. These aren't particularly small angles, right? 0.45 radians is not super, super small. Okay, so this guy's going to be your friend later, okay? So just understand that there's going to be two things going on. If you're talking about these separations here, okay, then this is what we want to do, right? And where D is going to be this little, the separation of this. So this little distance there, however wide this is, that's your D, okay? And you can see what's interesting here is you can see these are the, with Young's double slit, you just get these sort of wafty little things like that. And these peaks are very broad, okay? As you add slits like this, you start to get these little secondary maxima in between. Okay? And you have to, by the way, in this mark scheme, you have to refer to them as the secondary maxima. Okay, so these primary maxima, which are these guys, these get quite intense and sharp and well defined as you add slits until eventually you get to be like a diffraction grating, and they're really pretty uniform and very, very sharp. Okay, depending on how quality your diffraction grating is. Okay. But anyway, that's sort of what you need to solve this. This is what's going on here. Okay, so as you add more slits, these secondary ones get smaller. These guys get more sharply defined. Okay.